Hey, good morning, class. Mr. Bean here. This is going to be a presentation for honors physics and astrophysics, lesson 14.2, nuclear reactions. Um, so here you have this Google document, and in the yellow box, you're going to put your answers in. So here's this PowerPoint, which I turned into a PDF file, and it says here, nuclear reactions intro for honors and astrophysics. So radioactivity, this is a PET scan used for, called nuclear medicine, dealing with imaging and things of that nature for medical diagnostics. And of course, my cultural heritage, here is Godzilla. All right, so this will be slide number 1. So on slide 2 here, asking some questions, what is radioactivity? And you want to go ahead and explain it in the yellow box here. What's an alpha particle? Okay, and I should go ahead and maybe describe what an alpha particle is. And let me go ahead and do some annotations here. Let's put this up to the top here. So some annotations here. So first of all, alpha particle is basically helium atom without the electrons. So here's helium here, right? So helium atom has an atomic number 2, and it has 2 protons in its nucleus, and it also has 2 neutrons as well. So this is in its nucleus here. So you look here, there's 1, 2, 3, 4. So the atomic number is 4. Okay, so this is a helium particle, or alpha particle, which is helium without the electrons. And a way to describe this is, we'll go ahead and do this here. This is an alpha particle. This is the Greek symbol for alpha. And sometimes this might be written as helium, and with a dash here, helium 4. Okay, that's to signify helium here. Okay, you go ahead and hit pause, and you can also pause too if you need to record. Okay, pause recording. Okay, all right, now we're back to slide number 3 here, and here's slide 3. This is a new term called beta particle. It's an electron emitted during radioactive decay. So basically, it's a fast-moving electron, okay? So, and beta particle is usually given with the symbol B for beta, okay? It's a fast-moving electron, okay? And here's gamma ray, is high-energy electromagnetic radiation. Think of Godzilla, nuclear bombs, nuclear explosions, gamma ray bursts, or supernovas. Okay, and also here's what we call neutron emission. Okay, now what you need to do is click on this link right here and watch the video. It's going to talk about penetrating power of the beta, alpha, and gamma rays, and you want to describe in here what the penetrating power is. So go ahead, and I'm going to hit pause. I want you to go ahead and watch this video here, and then we'll continue on here momentarily. Okay, so now we're on slide number 4 here, and here's a list of the radiation types that we talked about, and also some new ones. Here's an alpha particle. We talked about the symbol for alpha particle, and here's its mass and its charge. Here's a beta particle. Okay, gamma ray looks like this. Now here's neutron. So neutron is written kind of like this right here with an N. It has 0 protons, but it does have 1 neutron. So we put a 1 up here. Here's its mass. Here's positron. So positron is like the evil twin of the electron. So beta particle, we said, was an electron. The positron is basically, it's an electron with a positive charge. It has the same mass, and has only difference is that this is a +1 charge and this is a -1 charge. That's the only difference between positron and the electron. Now beta particle we know is an electron. So we'll go ahead and write down electron here just to help us out here. Electron, okay, and there we go. And there's another particle called a neutrino. Okay, it has a symbol V, and the mass is close to 0. It's about 500,000 times less than the electron. So here's the electron is 10 to the minus 31, so 500,000 times lighter than that. That's a big number, and its charge is 0. Okay, so on slide number 4 here, it's going to ask you what can a positron be used for medically? Click on the link and answer it. And also, what is a neutrino? Answer that there. So I'm going to go ahead and hit pause, and we'll go ahead and let you go ahead and get caught up here, and we'll continue on with slide number 6. Okay, I'm sorry, I meant to say slide number 5. So we're now on slide number 5 here, and radioactive decay. And now here's this, we probably should went over this first, but just to remember what A, X, and Z stands for. X here is what's the actual element, okay? What is the element? So that's going to be, go ahead and write in here, element here. Element, and let me go ahead and write that in, okay? And Z is the proton number or the atomic number. What's the number of protons? We'll go ahead and put that in here, protons, okay, protons. And A is the mass number, and it just simply means protons, right, plus the number of neutrons. So protons plus neutrons is the A number here, and Z is the atomic number or number of protons, and X is the actual element, okay? Now up here, we have a new term, or it should be familiar, isotope. Isotope means something that has the same number of protons, but different number of neutrons. Think of cousins. They're related, but not exactly the same, or like siblings, okay? That's another way of thinking about it. So here's a hydrogen atom here. It's called protium. It just has 1 proton, therefore mass number is 1. Deuterium here is a hydrogen atom, but it has a neutron. So it has a proton and a neutron. And then here we have what's called tritium. Tritium is also hydrogen, but it's a hydrogen atom with 2 additional neutrons. So the mass number here is 1, mass number here is 2, mass number here is 3. Okay, and another example is isotopes of carbon. Here's carbon 12, which is the most common form of carbon, carbon 13, and here's carbon 14, which is used for radioactive tracing and telling how old something is. All right, we'll go ahead and let you get caught up here on slide number 5 here, answer these questions here, and I'll hit pause and let you guys get caught up here. All right, so we're now on slide number 6 here, and this is going to be introduction to nuclear reactions. Now from chemistry, remember we had balanced chemical equations. That was terrible because there's a lot of stuff on the periodic table. Well, when we balance nuclear reactions, we only have to remember 4 or 5 different things, okay? And give you an idea here. Now here's a link here for a periodic table in case you need it. Okay, we may have to click on this a little bit later. But this is called alpha decay. So you have a particle and then it breaks apart and gives off an alpha particle and it has something left over, okay? So take a look at an example here. Let me go ahead and do this here. So here we have, I think it's radon, and here we have, it has 88 protons, 226 is the mass number. Now see this this arrow here? Think of this as like an equal sign. Okay, now look at this here. Okay, so this is 226, this is 222, and this is 4. So 222 plus 4 is 226, right? And the mass number down here, here's 86. This is the helium or the alpha particle here, which is 2. So 86 plus 2 is 88. Okay, really cool, all right? Not too shabby. Now on B here, we have to figure out what is this unknown element right here based on the information we have here. So when I do this, think of this as an equal sign here and take a look at this. Here's 89 and this is 2. So think of 2 plus Z equals 89. What does Z have to be? So in order for this to work, it looks like it's 87 here, right? So there's 87 here. Okay, there's 87, okay? And up here, so this is 4 and plus A equals 217. So in order for this to work, this has to be what, 213? So we're going to put in here 213. So 213 plus 4 is 217. So the question is, what has atomic number 87? So let's go up here and look at our periodic table. And let me go ahead and open it up here. So here's our periodic table here. And it says here atomic number 87. Let's see where that is. So here's there's 89, 68. Let's see, where is 87 at? 80. Here's 87 right here. It looks like it's francium. Okay, so francium. So I go over here and I'm going to do the drawing here. So it's francium. So it looks like that X is going to equal francium. That's the unknown element here. Okay. All right. So what you guys need to do now, and let me go ahead and slide so a little bit here. Okay. So what you guys need to do now is for C and D, go ahead and do this on paper. And when you're done, use your Chromebook, take a picture, and insert the picture into the slide, into the yellow box here. Okay, so let's go ahead and hit pause, and we'll go ahead and let you guys catch up with that, and then we'll touch bases again on slide number 7. Okay, class, we're now back, Mr. Bean here again. We're now on slide number 7. And this is called nuclear decay beta particle. So this is a beta particle. And remember, beta particle is an electron. So electron here would be -1 here. And it's a 0 up here. So this is the symbol for electron. Okay, it has no mass here. And take a look at this example right here. So here we have, now this is the equal sign here. So we got to be very careful. So 0 plus 14 is 14, okay? Now here you gotta be careful. This is 7, this is -1. So we put an equal sign here. If I put an equal sign here, 7 plus -1 is 6, okay? So you gotta make sure that this is a -1 here. So we want to be very careful when you do this. All right, so for B and C here, I want you guys to tell me, what is this element? Okay, what is this element based on a beta decay? And we'll go here again. What is this element here based on beta decay? Okay, what is this? And if I look here, I'll let you guys go ahead and do that. So just make sure, we're careful here of what this needs to be. So make sure the left side and the right side are balanced out. So this is B and C. So you guys on paper, go ahead and do B and C. Use your Chromebook to take a picture of it and insert the screenshot into the box here. All right, if you have any questions, text me and we'll pause recording and let you guys go ahead and do that. And we'll touch bases on slide 8. Okay, class, for this last part, slide number 8 pertains only to honors physics. So astrophysics people, you are completed. Make sure you submit your assignment, and that is it. And now I'm only talking to honors physics people. So for honors physics, we're now going to talk about the positron. So here's positron. And what the positron is this particle right here. Remember, it's only thing different between positron and electron is that it has the opposite charge. So here's the symbol is +1. And notice here, this is +1 plus 10 is 11. 0 plus 22 is 22. And so this was called beta emission or positive beta emission, but this is called positron. And so question here is, which of these equations here represents positron decay? Okay, want to go ahead and answer that on paper. And then finally, what's the unknown element? Okay, what is this unknown element right here? What is it? Okay, so do your work on paper, use your Chromebook to screenshot it and insert the picture right here. All right, that concludes our discussion on 14.2, Introduction to Nuclear Reactions. All right, see you guys next time, and stay safe, and love you guys 3000.